we're supposed to construct sorry, that's probably better. A polynomial function with leading coefficient 2 that has this degree of 3 and these for zeros. So when you construct the polynomial, you should actually probably start with the zeros part. Because look, if -1 is going to be a 0, then I need to be able to plug in x equals -1 and the whole thing turns out to be 0. So how about this? So far, I've created a function that's a polynomial and -1 is 0, because if I plug in -1 in here, -1 plus 1 makes 0, right? But now I need to adjust it so that 3 is also a 0. So let's keep using parentheses, because now, look, if you plug in x equals 3, 3 minus 3 makes 0, and then 0 times 4, 3 plus 1 is 4, will also make 0. So that's the advantage of having it factored. And the last one, you can probably guess what I'm going to do. X plus 5, because if you plug in -5 in for x, you get a 0 here, and 0 will make everything else be 0. So check, check, check. We've done all that. Now, does it have a degree of 3? Yes, it does, because if you were to multiply these together, the result would be a quadratic, right? X times x will make x squared. And then if you multiply a quadratic to a linear factor, the x squared times the x is going to make x to the third. So degree of 3, that was checked when we did this. If it asked for a degree of 4, all you'd have to do is put an x out front, because that'll give you an extra 0, but that doesn't change any of these zeros. And you'd have x times x, that makes x squared, x to the third, x to the fourth. That would give you x to the fourth, like we're supposed to have of a degree of 4. Okay, so if that's what you got to do if it asks for a higher degree. If it asks for a lower degree, then you tell them to buzz off, because you can't do it. Okay. I actually don't know if buzz off is appropriate. Maybe it means something I don't want to say. So moving on, though, we need a leading coefficient of 2. So let's expand this. Okay. No, actually, let's wait. Before we expand it, I'm going to put a 2 up front, and here's why. Because when I multiply these together, you're going to get x squared for the leading term, right? The highest power term. And then when you multiply whatever this result is going to be to this, you're going to get x to the third, coefficient of 1. But if you distribute a 2 to everything, then you're going to have 2x to the third and then a bunch of other stuff. And we don't care what the other stuff is. We just need to make sure our leading coefficient is 2. So that's why I put the 2 out front, to meet that condition. Okay, so this is the polynomial. It's just not in polynomial form. What the textbook wants you to do is to multiply these two parentheses. So when you use your box method or whatever, you should get this. And then we're going to multiply these two parentheses. You could use the box method again. You're going to get x to the third plus 5x. I made sure to multiply x squared to both these terms. And then you're going to get negative 2x squared minus 10x. I multiplied negative 2x to both these. And then you're going to get negative 3x minus 15. And then the last step is just to distribute that 2 to everything. Oh wait, sorry, let's combine like terms before we do that. That would be way easier. Negative x squared, that can't be our only one. I messed something up. X to the third plus 5x. This is supposed to be squared. Maybe you noticed that. But when you multiply this, that should make 5x squared. Okay, 5x squared minus 2x squared makes minus 3x squared. And then negative 10x minus 3x makes negative 13x. And then minus 15. Okay, now we can distribute that 2. Okay, there's our polynomial. We just rewrote this, right, in polynomial form.